Talk about normal probability. Several of you have asked about skewedness in a graph. And so what that means is normal distributions, but I'm tacking on a little bit from yesterday's, and then I'm going to do normal distributions. When you graph, I think the one that we graphed first was symmetrical, and we talked about it being symmetrical. It was the dice roll where we added the two, right? So it fits to this nice curve. This actually what we call like a normal curve. It's perfectly symmetrical, okay? So that has no skewedness to it. It's symmetrical. When we get into the skewed, symmetrical, we're talking about the ends almost tailing off in a direction. So if it looks something like this, it's skewed in the direction that it kind of tails off to. So this would be skewed right. And this one would be skewed which way? Left. That's all it means to be skewed. Okay? Is the direction that the data is going. Now, it does not have to be one of those three. It can be neither. I mean, you could have data that's all over the place. But some of them show a pattern as to symmetrical, skewed left, or skewed right. Okay? That's all that means. Today, we're going to be talking about sets of data that are all symmetrical or normal. Okay? So that's where we get into normal distributions. Normal. Were y'all done with that slide? Okay, sorry. I hit record here. So the thing about normal distributions is they're always normal. They're always perfectly symmetrical. So you can always fit this nice normal curve that is symmetrical. That's a really nice one, actually. It's a little bit skewed, but that's not too bad. Thank you, thank you. So think about this. If I start thinking about a probability histogram, right? Each little bar that comes up represents the probability, right? It comes up to a certain probability. So if this represents an entire probability distribution, what should the area under the curve equal? Yes. Good job, okay? The area under the curve is 1, okay? Think about what we've done is we've essentially just taken those bar graphs. If you could split up a probability distribution into small enough little bar graphs, which Problem Stats does a lot, they'll get into that kind of stuff, and you fit the curve to it, this is what the curve would look like. So if we found the area of all the little bar graphs, all the little bars in the bar graph, it would equal 1. The area under the curve is 1. I probably should put under here, it's also symmetrical. Okay, so we talked about binomial distributions. We talked about any old probability distribution. This is another one. This is a normal distribution when it's perfectly symmetrical, okay? Now, if I cut this in half, let's say that this value was 5. Actually, no, let's don't use 5. Let's use 7. What's the probability that a value is less than 7 here? 50%. Remember, we're still talking about probability. Each bar represented probability. If the whole area is 1, then half of it would be 0.5 or 50%, right? I want you to see that we're still talking about probability is what I'm trying to get to. So, when we start talking about normal distributions, the middle, that very middle point right here, what I have is a 7 right there, is also, and I'm going to go ahead and tell y'all, this is not a Problem Stats book, and they interchange some things that hurts my heart. We have different variables that represent, I'm not going to get into all of it, but some of them are sample, some of them are population, meaning the whole thing, just a piece of it. One of them is the mean, okay? This middle line is always the mean in a standard normal distribution, okay? We use X bar to represent mean, okay? Mean is just the what? Starts with A. average, right? If you average everything together, that's an, so that always happens at the highest point right in the middle of your normal distribution. Now, there are some other measures of central tendencies and variance that we use when we start getting into prob and stats, and we're just going to talk about one of them in here, and that is standard deviation. Okay? It's a big word. We're not going to calculate it by hand, which you will do if you get to prob and stats. But what we are going to do is talk about what it means. So standard deviation measures how spread out the data is, okay? From the lowest to the highest. So in a standard normal distribution like this, what we know is that, and I'm going to throw some numbers up here, and these numbers you're going to have to remember, but I'm going to relate them all back to our curve in just a minute. 68% of all your data, yep, for all standard normal, is within one standard deviation of the mean. Now for standard deviation, I'm going to use the symbol It's a Greek letter, right? Sigma, right? You know, lowercase sigma? Huh? Standard deviation. So X bar is going to be our,
Where's the bar?
just represents mean. It just tells us mean. So if I were, and I'm going to go back to this one for just a minute. Yes, whenever you say it sounds like Greek to me, this literally is, it's Greek. Have y'all seen my little sign? Where's my mu sign? Oh. Is it covered up by something? I had a little sign for years, and it said, what do Greek cows say? Mu. Okay. If I let this be 7, okay? So if I have this set of data and I say, okay, guys, the mean for this set of data is 7. The standard deviation is 2. Let's just say I told you that. Okay? I'm just giving you a for instance. Tell me 68% of all data would lie between what two numbers? Yes. 9. 2, standard deviation is 2. So if I went up to 9 and down, that's telling me that between these two values, 68% of all my data is lying between those two values. Okay? If it's normally distributed. So that's what it means. That's why standard deviation, the bigger the standard deviation, the more stretched out your data is, the further out it goes. Okay, so standard deviation, the bigger standard deviation gets, the more stretched out your data is.
So we're not going
Okay,
to
so
use
one
that.
standard deviation away from the mean on either side, very much so. One standard deviation away on either side of the mean contains 68% of your data in between in that pink part right there. So the probability of having a value between 5 and 9 is 68%. 5 is what? No, well, standard deviation is 2. If standard deviation was 3, then I would be 4 and 10. You see what I'm saying? This is 7 plus 1 standard deviation, which is 7 plus 2. This is 7 minus a standard deviation, which is 5. Okay? I didn't want to define it as 1 because then you'd always think you only increase by 1s. Now, 68% of all data, I'm going to show you. 68% of all data is within 1 standard deviation. Also, 95% of your data is within 2 standard deviations of your mean.
It's the same thing, dude.
But now it's 95%.
Now I just color it in more.
So now, oh, wait till you see the colors we're fixing to put on this thing. We're gonna have, we'll talk about it in a minute. Yeah, put some more colors on there. Okay, so now 11 and 3, yeah.
Oh, so it's 2 for my standard deviation.
Now all this middle is 95%.
Where's the other one?
Oh, wait, just wait.
That's cold.
We're getting there, Wills, we're getting there. So that was 2 standard deviations, and then 99, oh, let me do another color. Wills likes all the colors. You can't do 100% because that wouldn't be real to life. So we'll do 99.7. We'll leave 0.3%, right? Within 3 standard deviations of the mean.
Wait, so can I try the numbers?
Huh?
Can I try the numbers?
Sure.
14 and 0.
No.
Why not?
I don't know. I haven't looked. Let me see. I can't remember what the numbers were.
Hang on.
No, if you add 2 more here, because standard deviation is 2, you get 3 standard deviations. Standard deviation is 2. So 2, 4, 6. Okay.
Oh.
So between the 2 purple lines is 99.7%. And as someone said, that leaves 0.3%, right? All right, so we're going to expand on this a little bit. I want you to draw, we're going to draw a big, big, big standard normal distribution, and we're going to derive all the little different areas in here and how much, what percent they are, because you'll use this to answer some questions. Standard normal is half. The other half is whenever you got a standard normal that it doesn't fall on the standard deviation. This is probably one of the most applicable, huh? Yeah.
That is true.
I don't know how big to
Why usually?
All right. I'm going to put my middle here. And this. You know those baby chicks have got to eat. Yeah. All right. So I'm going to put, right now I'm going to go ahead and put what I know. Okay. I know that 1 standard deviation. Now, first of all, remember, I said in the beginning this is symmetrical, right? That's really important to remember because the mean divides it evenly. The mean is the middle. All right, so 1 standard deviation away. So this is x bar plus and minus. Now, we all agree that between the 2 yellow dashed lines furthest apart is 68% of our data, right? Well, if that's 68%, then each one of the yellow bars should be how much? 34. Okay. I always remember as I'm doing this 68, 95, 99.7. That's called the empirical rule. I call them magic numbers. Yeah. This won't be that difficult. If I go out 1 more standard deviation, so now I'm at 2 standard deviations away from the mean. We know that between the 2 white lines is how much?
95.
95, but I've already used up 68. So what's left?
47 and 48, or 47.5.
95, that's exactly right, Dave. 95 minus 68 and then divided by 2, because you got 2 bars. No, what's 95 minus 68 would be 27. Divide that by 2 and it's what? 13.5. Is that what you said?
Well, I said the total is 47.5, is what I said.
You're talking about the half of it. The half of it, yes. Sorry. All right. Go out one more. You'll want to keep this somewhere really handy to have for your homework and everything else because you will reference it a million times. Okay, you should reference it a million times. 3 standard deviations away. So now I'm at what percent between the two pink? 99.7, but I've already used 95, so that's what? 4.7%, but divided by 2, what's it leave me? 2.35. Now, I told you that the entire curve was 1 or 100%. 99.7 is not 100%. It's actually 0.3% off from 100%, right? So what's left in my little tail areas there? 0.0, or actually no. 0.3%, so 0.3 divided by 2, 0.15%. All right. Let's set up a scenario. Keep this handy. Don't write it over it like I'm fixing to do because you don't want yours to be sloppy. Let's say you have a standard normal distribution that has a mean of, mean of 15 and a standard deviation of 3. What is the probability that your variable is less than or equal to 18? You don't have to make another one now. All right, now I always think about this. I do a little sketch off to the side and I'll say, okay, so this is the middle, this is 15. If I go up 1, down 1, oh, right here is where I need 1 standard deviation away, right? And so sometimes I'll even sketch a little thing here and go, okay, less than goes this way, so I need that area. So now look at the chart that we derived. 1 standard deviation to the right of the mean and everything below it. What percentage is that? 34 plus. Well, use what you know about the symmetry of it. The middle line from there left is what? 50%. 84%. 50 plus 34. Because here, from this line over is 50%, right? We know that because it's half. So we just need to add in this little to the 50%. Yes. So 68, no, 84, what am I doing? 84%. Yes. Now, your book is going to give you some where they don't define the mean and the standard deviation, and they say something like, what's the probability? So ignore these numbers over here now. What's the probability that you are greater than or equal to 2 left of the mean while still being between the mean. Look at what you're between. All you gotta do is look at what you're between. Look at the two outer numbers here. It doesn't really matter since they're giving you standard deviation and mean here like this. They're not defining them. I can literally use the derived chart that I have here. So minus 2 standard deviations is here. X bar is here. What's the area between the two? 47.5%.
Every time we do like one of these questions, we write this whole.
No, you may have to write one on your test whenever you start, but as far as your homework, you'll just be referencing this for most of it. But this is only half of standard normal distribution now. This is the easy half of it.
Oh my God.
No.
Are you doing overtime right now?
Yeah, in just a second. It's easy. I say it's easy. It's
easy for you.
okay. Let me set you up a real life problem real quick and then I'll move on. Let's say, I think I did our test scores in the video. Those weren't y'all's actual test scores, but it was just. But let's say I graded your last chapter test and I found that they were normally distributed. They are normally distributed with a mean of, and that's the key, is they have to say normally distributed. With a mean of, let's say 75 and a standard deviation of, standard deviation of 7 points. That's a pretty big standard deviation. That's a pretty big spread. This is McGee. Jose. Big boys. Jose. Big boys.
Oh yeah.
So think about this. Think about this with me for just a minute. What? I don't know. He didn't say. He just said send you to his office. What is the probability? What's the probability that you make an 89 or better? The probability that your score is greater than or equal to 89. I want y'all to do this. Y'all look at me like waiting on me to do it. Do it. Yeah. I will generally sketch a little picture because it helps me see. Oh, wait. I'm going to have to do.
Yeah, we don't have the.
No, that's right. That's right. I was right. I was right. What's your percent? All right, this is 1 standard deviation. This is 2 standard deviations. So I want the other side. So remember, if you're looking at your chart, this one's 50, right? So we know we're taking it out of 50 to start with. This is 34. This was what, 13.5? So if I take the 50... I want the other side. I want 50% minus these two. Because I want the y, I want bigger than 89. All right, look at your chart. Let me go back to the chart. I want bigger than 2 standard deviations. Come on, come on. Bigger than 2. So here's 2. So it's 2.35 plus 0.15. What is it, 2.5? Sorry, I hadn't done it yet. I didn't know.
2.5, right?
2.5. You don't need the other 50 because it's on the other side. What's the probability that you make below a 68?
Oh, a lot more. Below a 68, so that's 1, which is 13, 16.
What is it?
That's 16.
Why? Tell them why.
Because it's 68.
I'm not going to try to get into, I do want to tell you what happens. What would happen if I said, what's the probability that you make a 90 or better? What's the probability that you make an A? What's the problem?
You mean like
There's not a specific place for 90. 90 is not a magic number. What you have to do when you don't have a magic number, I'm just going to go and show you. It'll be easier, and then we can practice with it Monday. If I asked you what's the probability that you make greater than or equal to 90, remember my mean was, what was the mean? And the standard deviation was, so my magic numbers were those numbers that I listed along the bottom. But that doesn't have, so what I have to do is I have to convert it over to what I call a z-score. Not on your graph, question mark. Use a z-score. Here's what we do. We convert it over to find, z-score converts over to how many standard deviations away it is, okay? So we do x minus the mean divided by the standard deviation that's given. Okay? So for this, the z-score of 90 would be what? 90 minus 75 over 7. Round it out 2 places for me. 2.14. Take out your sheet. Look at the table that I gave you. Okay. Notice you have a negative side and you have a positive side, right? Okay. So I want to go to read this. I want to go to 2.1. Okay, on the positive. So go to 2.1. Do you understand how to find the 0.04 part? Yeah. 0.04 is across the top, so I'll find where they miss. What value do you see for 2.14? 0.9838. Now think about that with me for just a minute. So we stop for a second? Okay. Sorry. Sorry. 2.1 on the column, 0.04 across the top. The funny part about this chapter and this section, especially people that have struggled with so much before, will get to this and go, what are y'all talking about? This thing about that? See, this is all right, so 2.1 and then over to 0.04. Yes.
Oh, so it's like you add together.
Right, and then 0.04 up here, and you're going to find where they meet.
And what does each do?
So, what this does, listen carefully because this is where it will mess you up if you don't do it right. Remember our initial curve, okay? That was not 90. This is saying that there's a 98% chance. we looked at that data. There's not a 98% chance that you get better than a 90 on that test, right? Look up here at the curve. Look at which way it's shaded. It's shaded the other way. So you subtract it. Subtract it from what, Kiana? 100%, right? 100% minus 98.38%. So you have to be intuitive about it. What does it leave you? Somebody use your calculator. I don't know. 0.0. 1.62%. And look what we calculated at an 89, right? Bigger than an 89. This is very close to that, as it should be. It's only one value off. Does it make sense, though, how you're going to use the chart if your magic number doesn't show up on here?
Wait, you use the Z thing.
Yeah.
Wait, how would it have to add?
Say that again.
How would it have to on the graph?
So, like the one that we did, 89 was on the graph. I'm trying to go back, but 90 is not. Well, it's not going, for whatever reason, it doesn't want me to go back. There, see, 89 was on there, but 90 wasn't. So if it's on there, it's easy. You can use the chart that you derived to start with. No, not necessarily. On the other, the question is, what about the other side? It always shades left. It depends on what you're wanting to do. So for your Z-score table, if you're asked to find less than, I'm going to make a note of this in your notes so you have it. Okay. Z-score table. Less than is the way that it's shaded here. So as is. If it's greater than, then you subtract from 1. Should you start doing what, Corbin? I'm sorry. No.
That sounds so good.
We're going to go a little bit more in depth on this Monday because I want to find between two values. I'm going to give you some to try this weekend between two values. Think about this with me for just a minute. Think about this with me for just a minute. Look. Ooh. Let's say, guys, let's say I asked you to find this area. Let's say it was between two values, okay? So it was, because we did one kind of like that in the beginning, but they were those magic numbers, right? I could just add the columns together. But what if they weren't? What if they were Z-scores, okay? You'd have to do it for both, but look what happens. When you look up this Z-score, yes, that's exactly right, Silas. Good job. All right. If you look up the purple Z-score, it's going to give you everything from here over. Okay? If you look up this yellow Z-score, it's going to give you this. Well, to find the white, you would have to take the purple and subtract the yellow. That's how you find between two. Good job, y'all. I'm impressed.